Alright, hi radio fans. Well, some of you might say, boy, Bob, you really did it this time. What we have here is a Cubic 3250, which come as half-rack units. As you can see, I took the panel off and had it redone in black and made up some decals for some ancillary functions. It's not completely finished. There's a little audio work that has to be done, and I want to put in a couple of different antenna ports so that you could select SO239 or PNC or F fittings and that kind of thing. But primarily it's done and it's working. I wish this camera would show some of these things up close, but I don't know. Anyhow, it's a rainy, stormy day here in New England, and I figured I might as well get this on YouTube. So, very quickly, if you've seen any of my other videos, you know that a lot of this is the same stuff. We've got a modulation indicator here. There's a red light. The red light is a silent alarm or an idiot light. Tell you, there's no audio. So we put it back in, and you can see it's flashing between red and green as the audio modulates. That's modulation level up to plus 10 dB over. We've built in a preamp. I should shut that off. With a true RF attenuator and a preamp gain. We're giving this thing, I believe it's 12 dB, about 4 to 1. 4 to 1 capability, but that's selectable. Line level, so that you can send separate feeds or just control the detector output to the power amp. And the dBm reference levels for the line feed. And of course, a little power amp. I do a couple of watts with this. And the Italian house party's playing right now. But you can see that there's plenty of power. An indicator likes to show when we're running out of watts. Watts are important when you have a loudspeaker. Down below, we do some contouring just for comfortable listening, bass, treble, low pass, high pass. Here, I put in one of my special pre-selectors that I've been using for a lot of years. It's calibrated in bands. You can see you switch from band to band from 30 kilohertz. I'm sorry about this camera. I wish it was better. 30 kilohertz up to 30 megs. You can switch it in and out. Here you can bypass it. Here you select the band in decade increments, and this is fine-tuning to select whatever you got to do to get away from adjacent channel problems. It's pretty effective. At the lower bands, it's up to about 48 dB of rejection. The higher bands, it drops off to about 18 or 24 dB. But it works. You know, if you need it, use it. If you don't need it, leave it off. Here we've got a bunch of controls for antenna A, antenna B, so you can do low and high band antenna selection if you want. RF in and shunt so that we can ground it when not in use. Or just put it in the standby mode, just shut everything down. Internal, external D-mod. You can run a separate D-mod into this system. Another radio if you want to do diversity work or something. Well, it's kind of flexible. You can do a few things, but that's, it's up to the user to figure out what you want to do. If you're going to use internal, you're using the radio. External, you could actually do separate receiver diversity. I better do that in another YouTube because that gets kind of involved. Line in and out, so if you want to feed a recorder or send it somewhere, You could do that. It's line level, 600 ohms. Internal, external speaker. You have the option of playing it loud for if you're at the radio club and you want people to hear it. You go to the external speaker, play it outside. They can hear what you guys are talking about on the air. And mains control. Up on top, average modulation from the detector. This is integrated to about 1 or 2 seconds. So it will, let's see if we can. Alright. Oh, there we go. Well, he's, I don't know, the station's broadcasting this song that isn't very filling the envelope up very much, but there you are. They're running about 60-70% modulation. Then we go over here to the VU meter. This is doing average volume units. I'm going to get a better look at it. Average volume units. These LEDs do peak. So right now I'm set at +9. It's actually peaking at +9 into +10 and 12. But as you can see here, it's, if you can see that silly thing, it's hanging in there just at around +3 or so, because it's average. It's average. It's not seeing the peaks. So you can do both. And if you, this actually is broadcast quality, because you could use it for proof of play and so on, and doing field measurements for your radio station. If you're an SWL, it's going to be a lot of fun. And if you're a ham, it's a good monitor, or a sniffer. You go out and search for stations that are on the air. Sorry about the chair squeaking here. Hope that sounds like a chair squeaking. And the standard, if you're interested about the Cubic 3250, there's a lot of stuff online. You could actually go to the meter function, and it has meters for the RF, AF, and I guess that's the frequency shift for the BFO. This is one of those vacuum fluorescent displays. This is the second one I put in. A good friend of mine found one. These things are obsolete. The first one failed. God bless LEDs and LCDs, but we'll hold our breath that this one keeps working. Without it, you really don't have a radio. It's very friendly to operate. It's the DSP. It's direct digital synthesis. It's got a bunch of menus you can go through, but they're very simple, usually 1 or 2 level menus. Very easy to store things, and just generally a nice radio. Quickly up inside, and I'm going to try to get the lighting a little better. We have various audio circuitry and meter drivers. Here's the pre-selector inductors. Power amp drivers and meter drivers. This thing is a detector for the, you see the little chip, the modulation indicators. Got our own little power supply back here. We're getting a very clean 12 volts out of that thing. And I don't know. There's not a whole lot to talk about here. All the wiring, I try to keep it as modular as possible in case you want to change. So it's really kind of a prototype if you think about it. But there it is. Oh yeah, and a little the little Bob created preamp. I'm using video IC, video amplifiers for ICs. Anyhow, I'm running out of time.